In this demonstration, we'll be showing the effects of vinegar on a chicken bone, which relates to the topic of osteoporosis. Here is the chicken bone we'll be using.
Here is the vinegar.
Here's the jar we'll be using.
I know I gave it to you months ago. I know you're trying to forget, but between the drinks and subtle things, the holes in my apologies, you know, I'm trying hard to take it back. So if by the time the bar closes and you feel like falling down, I'll carry you home tonight.
I'm Tom Peterson. I'm 64. I've been here in Linwood for 34 years. I'm the only orthopedist in town. And I'm not going to be here much longer, so one of you ladies better hurry up to replace me. Basically, doctors get to be doctors by staying in school forever. In order to get from kindergarten to through high school, you go 13 years. Then you do another 13 years, 4 years of college, 4 years of medical school, 5 years of residency to get to be an orthopedist. So you start at 5 and you come out at 38. So you go to school forever. Orthopedics is a remarkably physical form of doctoring. You use hammers and chisels and saws and all that stuff. But the way everything works is based on the chemistry and physiology, based on chemistry, the genetics of it. And doctors are starting to get better at that. So that now they're talking about rebuilding tissue with polyethylene structures with mesenchymal stem cells, all based on the genetics that we can manipulate now. When I was in medical school, it was a big deal that they finally figured out the relatively simple amino acid pattern of insulin. And now they have a machine where you squirt something in one end and an hour later it'll tell you the protein pattern of the amino acids for thousands of them. And then you can teach a bacteria to make it. So that insulin that used to be from hogs and caused occasional allergic reactions as a result, we make in a vat of E. coli. So medicine is so much based on chemistry and the biology that chemistry allows, that the gross manipulations I do of putting fractures back together and surgery is almost undoctor-like, based on the fascinating way all this really works. For instance, when people have gout, they break down proteins and are no longer able to make the last chemical step. Birds that don't actually urinate, the flop you get on your car is full of uric acid. So it's good fertilizer, but it wouldn't come out in urine. So mammals take one further chemical step and break uric acid down to urea, which is dissolvable. And so we give them a medicine that helps them do that chemical step. And there are all kinds of things like that. Dialysis, for instance, that works to clean up chemical byproducts from the blood, gets rid of positive ions, so mainly sodium. but calcium is a double positive ion and gets dumped at the same time. So the mechanics of how the body absorbs calcium, manages calcium, puts it into bones, takes it out of bones, uses it for parts, is all screwed up by dialysis. And so there are all kinds of problems with the parathyroid gland, which controls absorption and use of calcium in the body. So even my mechanical specialty is full of chemistry. Bones are made out of mostly calcium and sulfate. They are living organisms. They have blood supply. They're full of fat in the center. The bone marrow makes new blood cells, cells that fight infection. There are cells that are constantly burying through the bones like moles or gophers, called osteoclasts. And they eat up the calcium sulfate and dump that into the blood. They are controlled by chemicals from the parathyroid gland that encourage their activity. The amount of calcium in the blood is in a very narrow pattern or range. Too much calcium in the blood makes you sleepy, may make you psychotic. Too little calcium in the blood and your heart may not work very well. You'll get tetanus and muscle contractions. So your kidneys are constantly dumping calcium. Your bowel is absorbing calcium from your food. Vitamin D that you get in milk helps the absorption of calcium, but it's activated in the skin and in the kidney. And we didn't know that until people started having kidney failure and surviving because of dialysis. And their calciums were dropping way more than they would expect, just because the amount that was showing up in the dialysis fluid. And it was because we didn't know about vitamin D being activated. The second OH group is put on in the kidney. So you then have parathyroid hormone coming from the parathyroid glands trying to get you to absorb calcium. You have parathormone coming from the parathyroid gland that gets you to dump calcium. Your heart doesn't work if the amount of calcium in the blood isn't right. And they have calcium channel blockers to adjust how your heart works, because we're learning more and more about calcium. Let's see, if you eat things in the cabbage family, it prevents the absorption of calcium for 24 hours. So if you eat a lot of broccoli, then you're going to get soft bones. Spinach is good for blood because it's full of iron, but it makes soft bones. So I tell people that's how come Popeye's arms look so funny. Okay.
It's been about a week and we're back to observe the results.
This experiment shows what happens when an acid comes into contact with calcium phosphate.
As you can see, the bone has become bendable.
The bone dissolves and loses its structure, causing it to become flexible.
This concludes our experiment.
Give me a second, I need to get my story straight. My friends are in the bathroom getting higher than the Empire State. My lover, she is waiting for me just across the bar. My seat's been taken.